you get to hear me now.
Alrighty, so we have a warm-up, and first we're gonna do limits. So the first 5, we're asking for the limit as we approach 1. At this point, you may want to pause the video and try them out, and if not, then you're pretty much cheating, so shame on you. Just somewhat kidding, just kidding to a degree of 1. Limit as we approach 1, which implies we're approaching this destination from both sides. So the limit would be 1. When you approach 2, we are approaching from the left side, we're going to end up getting 2, and from the right side, we're going to end up getting 3, so they don't agree, so that does not exist. If you go from the positive side, the limit as you approach 2 would be 3. As we come to 3, the limit would be 1. And as we approach 4, the limit would be 2. Let's continue. To find the individual functions, we don't care about the surrounding areas, the neighborhoods, we just care about the certain point. So function of 1, so when the domain is x equals 1, is the y would be 2. So that would be 2. And then for 2, this is a closed dot, that's an open dot, which means that 2, x equals 2 only exists right here, so that will be 2 as well. And then 4 does not exist. I'm not seeing any dots, so if that was a dot like right here, it would exist, but that's not the case. So in this case will be does not exist. And then for 3, the limit and the function agree, it's 1, which also is one definition of saying that it's continuous. Anyways, so that will be 1. In the previous video, I talked about the techniques for evaluating limits. There's the easy substituting in, that's the limit does not have a 0 in the denominator, or just doesn't have any problems when you just plug it in. Then there's factoring, you might be able to actually simplify it. The conjugate method is also a way to simplify something better that would eliminate having a problem. And then another simplification method, which is multiplying by the least common denominator. If you have a fraction with individual fractions inside of the fraction, a lot of fractions and fractions, then you can just find the least common denominator of all the fractions and multiply the top and bottom of that fraction. So for each one, let's do one example. This one right here, you can see that we have a problem, because if you simply plug in -2 in the denominator, we're going to have a denominator of 0, and that's not good. But I am noticing that we can factor this. So this is going to be x plus 2, x minus 2. On the denominator, we have x plus 2. By the way, we're still talking about the limit. And the x plus 2's go away, leaving you with a limit of x approaching -2 of x minus 2. You can now plug in and end up with -4. Over here, for this one, what's the issue here? If you were to simply plug in 3, the denominator would go to 0, and that's a problem. So you need to again factor the top if possible, hopefully it does. 2 numbers to multiply would be 12, but add up to be -7 is -3 and -4. So we have x minus 3 and x minus 4 now, and the x minus 3's will cancel, but do not forget that's a limit. Should have put that also in while I paused the video. Alrighty, so x minus 3's cancel, leaving you with a limit of x minus 4, which ends up giving you, I'm going to put an equal sign, of -1. That's the answer. Over here we have some more examples. In this one, we're going to be using the conjugate method, and then over here, the least common denominator. So let's get started. So to talk what the conjugate is, it's pretty much when you have, let's say, an a plus b, the conjugate of that would be a minus b. So as you can see, I did get the conjugate of the numerator, and here's the hope. I'm hoping that once I multiply by the conjugate, that on the top I will end up with x minus 3, which will cancel out with this x minus 3. The reason is, I know I can plug in 3 over here. There's going to be no problem. So if this is left in the denominator, I'm good. The x minus 3 is what I'm trying to eliminate. The problem was probably set up in a way where this is going to work out. So let's try it out. So the numerator ends up being x square root of x plus 6 squared, and then minus 3 squared, which ends up giving you x plus 6 and minus 9, which will end up giving you x minus 3. On the bottom, we also happen to have an x minus 3, which is really good. So let's cancel out the x minus 3's. They cancel, leaving you with a 1 over the square root of x plus 6, and then outside the square root plus 3, which when you plug in 3, you're going to end up getting 1 over square root of 9 plus 3, which is 1 over 6. How nice. Awesome. There's not going to be a plus or minus, because we're not guessing what the value would be, since we are substituting a number that we exactly know. Alrighty, for the next example. When we want to solve this, we notice we have several fractions inside of fractions. So a good idea to get rid of all these fractions is to multiply by the least common denominator, since we cannot simply plug in 0. You plug in 0, you're going to have a problem right here. We don't want that. So what's the least common denominator? It would be just negative 4 plus x times 4. So let's multiply that on top and bottom. We notice that for this fraction, we're going to end up canceling a denominator, be left with 1 times 4. So that would be a 4. And then when we multiply by right here, the 4's are going to cancel, leaving you with a plus negative 4 plus x. And then the denominator of the whole thing will just be all of it. So 4x and negative 4 plus x. Don't forget the limit. Now that happened, we can further simplify, because the x's now cancel, which is the only problem we had with the denominator, leaving you with a 1 over 4 times negative 4 plus x. Now we're free to plug in, so we are going to end up getting 1 over 4 times negative 4 plus 0, otherwise known as negative 1 over 16. Easy peasy, lemon squeezy. Alrighty, for these 4 problems, please pause the video and try to simplify them on your own. See which factoring method or solving limit method you want to be using, and you can press play when you're done doing that. Alrighty, let's get started. I'm going to first simplify all of these, and then I'm going to talk about them. Okay, so I simplified it. The first one, I factored the top and bottom, ended up with x minus 4x minus 1, and then on the bottom x minus 4, which is what I wanted, and then x plus 2. So we can see that we can cancel out the x minus 4's, which will make this a lot easier, because now, since the limit is x minus 1 over x plus 2, we can simply substitute in 4, which gives us 3 divided by 6, or 1/2. Now for the second one, we also got what we wanted, because the x minus 3's cancel. And now we can again plug it in, so we end up with 3 squared, which is 9, plus 3 times 3, which is 9, plus 9, which is 27. That was 1/2, by the way. Looks bad though. Now for the third one, we have a conjugate. We needed to simplify, by the way, that's a limit where x approaches 9. we needed the top to look a little better. Hopefully that's going to end up being x minus 9, which it will. So when you multiply the top, that's going to be x, 3 radical x, and then negative 3 radical x, and then a negative 9. So we're going to end up with x minus 9 divided by x minus 9, which gives me 1. I don't even need to plug anything in. And then for the last one, it's going to simplify really nicely. So please make sure that the denominator you do not distribute, so do not multiply the x minus 1 times x plus 2, since the top is going to become, I'm going to go ahead and just write on top of it with a different color, it's going to end up being, it's going to be negative x minus 1, but if you factor out the negative, you're going to end up with x plus 1. So this ended up being negative x minus 1, but I need it to look like one of these bad boys. And I can make it look like this by factoring out the negative, which gives me the limit of negative 1 over x plus 2. And when you plug in a negative 1, you're going to end up with negative 1 over 1. Alright, that's it. Go ahead and pause the video again and try these problems right here. I'm going to simplify them in a moment. So to simplify them, I use these methods right here. For 5, I use the conjugate of square root of x minus 2. For 6, I can use the conjugate of square root of x plus 14 and then minus 4. And for the last one, whoever made this problem, really, 2 plus x. I refuse to rewrite it as 2 plus x. So I've rewrote it as 2 times x plus 2. Just the way I like it. So, pause the video again and make sure you simplify it correctly. I'm using an iPad to record this, and I'm really low in space, so forgive me that I didn't write down the limits, but just to satisfy some needs, limit. Alrighty, so for the first one, it's really nice. The x minus 4 cancels, boom, boom, ending up with square root of x plus 2. The limit was a 4, approaching 4, which would give me a final answer of square root of 4 plus 2, or 4. Now for the next one, we plug in a 2. Oh, wait. What do we have to do now at this point? The x plus 14 minus 16 is x minus 2. So this will cancel this, leaving us with 1 over that denominator. Plugging in 2, you would end up with 1 over, and then square root of 16 is 4 plus 4, otherwise known as 1 over 8. So when we simplify, we end up with the numerators before, but 2 minus x minus 2 would end up giving you negative x. The x's cancel, giving you negative, let me go ahead and write it, negative 2, and then x plus 2. The negative is irrelevant because you're going to end up getting 0 when you plug in for the limit, so that's going to be negative 0, or you can just write 0. Alright, for number 8, I need you guys to come up with a problem that's similar to the ones we just did and solve it. So number 8, I need you guys to have that in your notes when I check them. Make sure that number 8 is a creative problem and make sure that it's all the way solved. Alrighty, talk to you guys later.